Welcome. In this tutorial we are going to learn about class and object. Class acts as a template for creating objects. It defines attributes and method of objects. You can see class as a collection of common attributes and method of related objects. Now object. Object is an instance of a class. It can be a real world thing which can be touched, seen, or can be interacted, such as ATM machine. It contains facts in terms of data and how object can be interacted with it in terms of methods. It can hold the state of real world entity such as switch, which can be either in on or the off state. And object can also be interact with each other using methods. Now we will see how to create class and object in Python. So for defining class name should be in caps word, and in Python there is no restriction on defining a class that must have same name to the Python file name. So in other language such as Java, you need to define the file name same as the class name inside it, and in Python in single module you can define multiple classes. So here is the syntax of a class. You can define class using class and class name. So here we are defining empty class, and in order to create object of a class you need to invoke constructor of a class using this. So inside this we can pass parameters to the constructor of a class. So here we have not defined any constructor, so it will create an empty object. So let's create empty class and empty object. So here as we can see, it has created a bank account object, and it has also defined a bank account class. Next we will create a constructor for the class in order to configure the object. So constructor creates a new object and configure it according to the given parameters. So constructor in Python is defined using init method. So as we can see here, it is defined as a init method. It contains self as a first argument, so it is a mandatory argument. You need to pass it as a self, which refers to the current object. So its name can be anything, but first parameter refers to the current object being created rather than the other parameters. So it is an implicit argument which is passed when creating a new object. So you don't explicitly pass this argument while creating a new instance of a class. And init method can take positional and the keyword argument, same as we saw for the functions. And argument passed to the init methods are normally stored as a data attribute of an object. So here we have created init method which is having first parameter as a self, which is required, and we are taking one parameter account number and we are storing or attaching to the self. Means we are creating an instance variable, so we are attaching that variable to the instance of a class, and inside the constructor we are printing this message, so we can know that we are constructing a new object with this given parameters. Okay, so first we will construct a object of bank account, and here it is taking one parameter account number, so account number is passed. We are not explicitly passing the self, so it is implicitly resolved by the Python. So whenever the new object is created, that new object is referred using this first argument. So let's create object. So as we can see here, it has created a new object of bank account, and it is printing the output of a print function creating new bank account from the parameter which we have passed inside the constructor. Same way, you can also pass keyword argument to the constructor of a class. It has same rule as we saw for the functions. So it will create an instance of a bank account, same as we saw for the earlier instance. Next is variable. So class contains two types of variable, a class variable and the instance variable. So class variable is a variable defined at the class level and are called using either class name or the instance. So class variable are the variable which are defined at the class level, and for each object of a class their value remains the same as defined in the class definition. And class variable can be accessed using object of a class or using the class itself. And changing the variable value of a class variable, it is visible to all the objects. In contrast with the class variable, instance variables are attached to the instance of the class, so they are different for each instance, and changing the value of one instance variable to particular object does not affect the other values, and they are defined generally inside the constructor of a class or the init method. And for each object of a class, their value is configured as per the parameters given inside the constructor. And instance variable can only be accessed using objects. So now we will define both kinds of variable and we will access it. So here at the class level we have defined a variable. So this variable becomes a class variable, so it can be accessed without creating any object of a class. So using class name we can access it. So let's execute it. As we can see, it is returning the value defined as a class variable. Now same value or the same variable can also be accessed using object of a class. So here we are creating object and we are accessing the class variable using object. So it is returning the same value. So for each object, the value which is defined at the class level remains the same, but for the instance variable it varies as per the constructor parameter passed while creating object. So here we have created the object which contains the bank account. So bank account number, so account number will be different for the each instance, whereas the bank name defined as a class variable will remain same for all the instance. Now next is methods of a class. So class have three types of method. First one is a instance method, which accesses and modifies the instance variable. So earlier we saw instance variable which are attached to the object. So to access and modify those variable instance method is used. It can be accessed on instance of a class only, and it can call other instance method, class method, or the static methods. So other two methods are class method and static method, which can be invoked inside any instance method. And same as the constructor, it takes one implicit argument as a self, which must be the first parameter of a instance method, which points to the current object on which you are invoking the instance method. The object on which instance method is invoked is passed as a self argument implicitly. So while calling the instance method, you don't pass any argument to the self. So any other argument defined after the self, you need to pass to the instance method. Second one is a class method. It is defined using @class method decorator, and it accesses and modifies the class variable, and it can be invoked without creating any instance of a class. So earlier we saw class variable, so same way class method can also be invoked without creating any object, and it modifies the class variable only. You cannot access any instance variable, and it takes one implicit argument CLS, which refers to the current class that is being accessed. It can also be accessed using object of a class. So you can also invoke a class method on an object, and it can call other class method and static method, but it cannot call any instance method, because without creating any object, you cannot access the instance variable. And third one is a static method, which can be defined using @static method decorator, which acts as a utility method which performs operation on given parameters only. So whatever the parameters passed inside the static method, it performs some operation and it may return the any result. It can be accessed without creating any object of class, and it can also be accessed using object of a class, and it can call any other static methods only. So now we will define three types of method inside the class. So here in bank account class, here is a init method which takes two parameters, account number and name, which are attached to the self. So they are instance variable, and bank name and interest rate are the class variable because they are defined as a class level, and the class variable are generally defined in a capital letters, so they can be differentiated with the instance variable. So first we will define an instance method. So you can identify instance method using its first argument, which is defined as a self, which refers to the current object on which we are performing operation. So here it is returning current object's instance variable name. So value of instance variable name will be returned by this method. Next, we are defining class method. So first we need to decorate the method using @class method, and first argument is a CLS, which refers to the current class on which you are invoking the method. So it is accessing a class variable interest rate, and it is returning its value. Same way you can also modify the value of a class variable using class method. So here it is taking one parameter, and that parameter value is set to the class variable. Next is a static method defined using @static method decorator, which does not take any implicit argument, so just normal function, and based on that parameter passed to it, it may or may not return the value. So here we are returning a boolean value depending on the value passed to it. Next is an instance method which are calling other methods. So first one is a self.getName is a instance method. So instance method invoking other instance method. Same way you can access instance variable inside the instance method. You can also invoke static method inside the instance method, and you can also invoke class method inside the instance method. Now we will access these methods on the object and the class if it is permitted. So first one is a static method, so which it can be invoked either on a class or the object. So first we will invoke on the class. So without creating any instance, it can be invoked, and it can also be invoked on the object of a class. So here we have created bank account object, and on the bank account object we are invoking the static method. Same way class method can be invoked without creating any instance. So by writing class name dot the name of the class method, we can invoke the class method which will return. So we are invoking get interest rate, so it will return the class variable value interest rate. Same method can be invoked on the instance of a class. So here on the instance of a class we are invoking class method which is returning a value of a class variable interest rate. Now we are accessing instance method. So instance method can only be invoked on the object of a class or the instance of a class. So we have created the instance of a class, and we are invoking the instance method which will return the name of the bank account holder. So if you try to access instance method on the class, it will give you error because it will not pass a current object. We are referring to the class. Now earlier we defined an instance method which were calling other instance method here. So we can invoke on the object which will return the return value from the all other methods. So as we can see here, it is in returning instance variable value, invoking the static method, returning its value, and returning the value of a class variable. Now we will see in details how the self implicit argument is passed to the instance method when it is invoked. So earlier we saw function. So all the required parameters or the attributes of a function you need to pass in order to invoke it. But here, while invoking the instance method, we are not passing this first parameter. So how it is resolving it? So first we will invoke instance method without passing any parameters. So here we have defined an instance method which does not take any explicit argument. It has only one argument, which is a self, which refers to the current object on which the method is being invoked. So if we create an object of it and invoke it, it will return the value of a instance variable as defined inside the instance method. So what exactly happens when we are invoking this instance method? So this call object dot the name of instance method is converted into class name dot instance method name, and inside the parenthesis the object is passed. So using the same call we can access this instance method. So as a self parameter, this is instance itself is explicitly passed. So while invoking this, now you know what the value is passed as a self argument implicitly. Next is referring class variable inside the instance method. So earlier we saw instance method can access or invoke other instance method, class method, or the static method. So you can also access class variable inside the instance method. So there are two ways in which you can access class variable. First way is you access class variable using class name dot the name of variable defined at the class level. So class variable, class name dot class variable, using it you access it, or you can access using the self argument. So self refers to the current object. So earlier we saw you can also access class variable on the object, and we also saw that particular object on which you are accessing attribute, it is object itself is a passed as a self implicit parameter. So using that parameter you can also access the class variable, but there is a difference when you are modifying the class variable. Okay, so we will see with the example. So here we have a class variable bank name and a class method which returns the bank name, and an instance method which is also accessing the bank name using self. So it should also return the same value of a bank name. But if you are setting the value of a class variable using self, then it will create a problem. So as we saw earlier in constructor, when you are assigning a value to the self, attribute is created on the object instead of creating on the class. So while you are modifying the value of a class variable using self, instead of modifying the class variable, it will create a new instance variable inside the object. Okay, let's see it with the example. So we have created an object of a bank account. First we will access the bank name in a class variable using an instance method referring to the self. So if we invoke it, it is returning the name of the bank using self parameter. And same way, if we are accessing using class method, it will return the same name. Okay. But when we modify using self parameter, here we are modifying it using self. Now if we, after modifying using self, if we check both the method, one is referring to the class and returning the class variable, and one is returning the same, trying to return the same variable using self. So as we can see here, the self method is returning the latest value which we have assigned using self, and the class variable is returning the old value. How it is happening? So first we need to understand how this accessing attribute of a class variable works with the self. So when you are accessing a class variable using self, it works as a class variable as a fallback. So first it will check that any instance variable is attached with the self with the given name. If it is attached with the given name, then it will return the variable value of a instance variable instead of a class variable. And if it is not having any instance variable attached to it with the given name, then it will look for the class variable of a given name. So in this case, first it was not having a bank name as an instance variable, so it was returning the value of a class variable. But when you are invoking the set bank name using the self, here you are creating new instance variable instead of modifying this class variable. So if we check here, bank account dot bank name, still it is holding ABC Bank instead of XYZ. So the class variable is holding ABC Bank only, but on the instance new variable is created, same name as the class variable name, which will shadow the class variable name. It is having value XYZ Bank. So now if you are creating another object with some different values, and if you are trying to access bank name, so it will refer to the class variable because this object is not having any instance variable with the given name. So here we are referring to the class variable. So always remember, whenever you are accessing a class variable, refer it using class name dot variable name in order to avoid confusion. Now we will see in detail how and where does the class variable and the instance variable are stored, and we will understand when invoking or when assigning a variable using self where it is creating instance variable. So same. So dictionary is a special attribute which contains attributes which are data attributes and the method attributes of instance or a class inside it. So whichever attribute defined at the class level are stored in the dictionary attribute. Same as for the instance, whatever instance variable you are creating inside the constructor, they are stored inside the dictionary. So first we will create class and its object. So here we have created bank account class and 2 bank account objects. Now we will see the attributes of bank account class and its object and see where and how those attributes are stored. So using this dictionary attribute, we will access the keys. So accessing this dictionary attribute, first we will see the class. So it contains, as we can see here, it contains the class variable, bank name, init method, class method, static method and instance method defined on it. Okay, and if we check instance method or the instance dictionary, as we can see here, whatever the attributes attached to this self is visible here. Okay, so for the same example we saw earlier, which were modifying the class variable using self, if we check its dictionary after modifying it, so here we have modified the value of a or we are trying to modify the value of a bank account class variable, but instead of bank account class variable we have created a new instance variable. So we can see here we haven't created any instance variable inside the constructor, but the new instance variable is created when you are modifying the or you are trying to access or you are modifying the class variable inside the instance method using self parameter or on the object. And if you compare the object of or the dictionary object of 2 objects, as we can see here, it contains the variables defined inside the constructor and the values which are passed when creating the object. So instance variable are stored on the object and class variable, class method, instance method and static methods are stored on the class. So whenever you are creating an instance of a class, those methods, class variable and all the instance and static methods are also accessible. So if you check the object of a class, you can see all the attributes which are defined at the class level. So you are inheriting those attributes when you are creating the class. So as we can see, this class acts as a template for creating the object. All the attributes which are defined here are accessible using this object. Okay, here we can see inside this object all the attributes, data and methods are visible here. And you can also access attributes. So we are accessing attributes like this: object name dot instance variable name or the class variable name. Same way you can access using dictionary. It will return the same value because now we know it is stored inside this special attribute dictionary. Next is type function. It returns the object class. So we have object and we want to know what is the class of it. We can invoke type function. And same can be accessed using special attribute class. So here we have invoked this on this object and it is returning the class of it, which is a bank account. Next topic is mutability of attributes of class and object. Attributes of class or object are just a dictionary entry, as we saw in a dictionary attribute. So that dictionary can be modified to contain any value. So original value, after constructing an object or a class, you can modify it as per your requirement. And now we will modify those attributes after creating object or the class for the demonstration purpose only, and you should avoid modifying attributes or the methods of a class or an object after it is defined. Modifying in terms of not the value, but we are modifying the type of value also. So we will see it with the example. So here is the first example. So here we have created a class bank account, and this is a normal function which is taking one parameter. So we are attaching this function to an existing class definition like this. So the new parameter or the new attribute will be created on the class. So first we will print the dictionary attribute of bank account before modifying it and after modifying it, so we can get the better idea what is happening. Now here we are creating a new attribute of on the class of bank account, and we are assigning this method. So this method will become an instance method because it is referring to the current instance of a class, not just by naming this as a self. You can give any name here, but we are referring to the instance variable, and this is a first implicit argument, so it will return this value of a instance variable. Now we will assign it to the class and we will see what changes it makes to the dictionary of a class. So here we can see get account number function with the bank name attribute is added to the dictionary, which is replacing the class variable. So earlier in the definition we can see bank name is defined as a class variable, so it is replacing that class variable with the function. So this way you can modify it, but you should not modify it like this, but this is you can do it. So after assigning it, if you are invoking it on a instance, because it is defined as an instance method, it will return the value of instance. So this is a account number set as a, and invoking this method bank name will return account number instead of returning the value of a bank. So this example gives you an idea about after defining a class, any attribute, even if it is a data attribute or the method, which can be modified into the some other types also. So same way, if we are assigning here method name equal to a variable value, so it will replace that particular function with the data attribute. Now next is assigning value to undefined instance variable of an object. So earlier we saw whatever the value we are attaching to the self are created as an instance variable. Now what will happen if we are assigning to a variable attached to the object which is not defined currently on the object or instance level or at the class level? So first we will create two objects of a bank account which is only having single instance variable account number. Now we are trying to assign name to it. It does not have any instance variable or a class variable or any method with this name. So if you're trying to assign unknown variable value, it will create a new instance variable with the given name to it. So after invoking it, if we check the dictionary of a B1, because we have invoked on the B1 object, it will contain a new attribute, data attribute with the given value. So even after creating object, you can assign a new data attribute or the method attribute also. So same way, if you are assigning here instead of string, you are assigning a function, so it will create a new function attached to that object only. It will not attach to the class. So it will not affect other object also, as we saw for this. Assigning the name to the B1 object does not create a data attribute for the other object because two objects are separate. But instead, if you are defining at the class level or a class variable, instead of here you are defining a class name, then it will affect all the objects. So here we are adding a class variable after creating a class definition. So here we are having only one class variable, bank name. After creating a class, we are creating two objects, B1 and B2. Okay, and if we are checking the dictionary attribute of it, it is only containing the account. Okay, and if you check with the dir, it is only containing one class variable, bank name. So same will be true for the B2 object also. Now here we are assigning a variable value, a float value, to a class variable because we are invoking on a class which does not exist inside the class definition. So it will also, same as the instance, it will create a new class variable on this. So after invoking this, it will create a new class variable in the class definition. Now if we are invoking, or now if we see again, as we can see, a new variable or the new attribute appears inside the directory of a B1. Same goes for the B2 also. Okay, so if you are creating or attaching a new attribute to the class at the class level, then those changes are visible to the object. Now we can also access this new value using instance also and the class also. So if we try to print it, it will print the given value, which is defined after creating the definition of a class. Same way you can also add class method after creating the definition of a class. So here we are defining a class method, and after defining a class method, we are attaching the method attribute to the class definition. So after creating attaching this, the newly attached class method can be accessed on the class. Now this does not make sense here at this stage, that we are modifying the data attributes and the method attributes after creating the class definition. But when we see decorators in upcoming session, you will see this functionality becomes quite handy when you are creating or the modifying the class using decorators. So you can attach a common functionality and other useful cases to the class or the object. So same way you can also attach a static method to a particular class. It is same as we saw for the class method. So instead of class method, it is a now static method, which does not refer to the any implicit argument. So any argument of a defined method is a required parameter. And earlier we saw for the class method, it takes one implicit argument class, which we are not passing explicitly when we are calling it. So same way, instance method can also be attached to the instance or the class too. So here we are attaching the instance method to class, which will be access to all the instance of a class. And if you are attaching this instance method to a particular instance, then only that instance can access it. Now here, as you can see, we are attaching to the class. So this method get account number will be accessible to the all the instance of a class, which returns the value of an instance variable account number. So after attaching it, we are invoking it on the objects. So as we can see, it returns the instance variable value as per the object, and the value is it returns is as per the given value in the constructor of a class. Next, we will see attaching the instance method at the instance level. So earlier we attached to the class definition, now we will attaching to the one of the object. So here we are attaching only to the B1 object. So if we check the dictionary object of all the object and class, we can see here get account number is only defined inside the dictionary of a object of B1 because we have attached to that object only. So it does not affect the class definition and also the other objects dictionary. And same way, if you are invoking it, it will return the value of a instance variable which you are accessing inside it. Okay, so here we are accessing the instance variable. Here we have used a closure. We will explain it in decorator session in details how this is achieved. Okay, but for this demonstration purpose, we can attach the instance method after creating the class definition, and we are attaching that instance method to the object of a class. Now next topic is access modifiers. So in other language such as Java have access modifiers such as private, protected and public, which limits the visibility of data and the method attributes. So for Python there are no access modifier, which means all the attributes you are defining at the class level or the instance level are public by default. Now it may sound as a limitation, but we can restrict it. But by default they are public and you cannot write any access modifier to make it private. There are other ways to make it private which we will see, but by default they are public, which means here we are defining a instance variable, we can modify it outside the class. So as we can see here, after modifying this, it contains the new value of the instance variable. Okay, and as we saw earlier behavior of attaching any new attribute to the class or the object, that can also be avoided. We will see in the upcoming session how to avoid it. Now in order to define a pseudo private variable, there is a concept called as a name mangling, by which we can avoid modifying the pseudo private variable. Okay, so we know that Python does not have any access modifier, so Python variable cannot be private. However, in order to avoid other developers from modifying the private variable of a class, we can mark a particular variable as a private by prepending double underscore before the variable name, so which will mark it as a pseudo private variable. Now what does it do? Pseudo private variable attribute cannot be accessed directly using given name beginning with the double underscore, but it can accessed using underscore class name underscore double underscore attribute name. So it will avoid directly accessing that particular attribute. Okay, we will see with the example. Now what happens internally is their names are mangled when you are defining any attribute beginning with the double underscore. So their attribute name is automatically modified into this name. So if you are defining double underscore attribute name as any attribute of a class, it will be converted into this name underscore class name double underscore attribute name. So in order to avoid directly accessing that pseudo private attribute, and that can be visible using dictionary attribute. First we will define it and we will see it. So here we are creating bank account, and we want to make amount of a bank account as a pseudo private variable. So we have defined its name using double underscore in the beginning, which will make it as a pseudo private attribute. And we have one private method which is a print account, which has also defined named as a beginning with the double underscore. So it is also a pseudo private method. And after creating a class and object, we will try to access it using its name. Okay, so here we have defined the class and create an object of a class and invoke a public method deposit. So it is having 500 as a amount. Okay, so deposit will modify this attribute because it is a instance attribute, so that pseudo private attribute can be accessed with the same name beginning with the double underscore inside that particular instance method or the class method as per the defined attribute. So inside the class their attribute name remains the same, but when you are trying to access it outside, the same attribute name cannot be accessed with that same name. So if you try to access amount using the same name which you are using inside the instance variable or the any methods inside the class, that attribute cannot be accessed. Or either you are removing this double underscore, then also it will give you error that that attribute does not exist. But the same pseudo private attribute can be accessible using underscore the name of the class and double underscore the name of attribute. So if you try to access it using this, it will return the value of that pseudo private variable. And if you check the dictionary of an object or the class, you will clearly see that name mangling has been done. Okay, so we will check for both the pseudo private method and this is the pseudo private instance variable. So this is the instance variable, so it will not be stored on a class. So they are name mangled in order to avoid direct access to the pseudo private attributes. Now, Python programmers suggest not to use double underscore in order to define a pseudo private variable. Instead of it, the private variables are defined using single underscore, which does not do any name mangling as we saw for this, which simplifies for that, and they use as a convention, so other developer also follows and avoid accessing variable which begins with the single underscore. Okay, so same single underscore variable name can be accessed directly, but when we are accessing it, the developer themselves know that they are accessing or trying to modifying that private variable, and they should avoid it. Now, one thing to here notice is name mangling can also avoid a collision when you are using multiple inheritance with the parents having attribute with the same name. For example, here we have two class, land vehicles and water vehicles, which is having instance variable max speed with the same name. So here we are using name mangling. So while inheriting both of the parents class having same attribute name, it will attach class name before the attribute name, so it will avoid collision. So after creating the class, if we check the dictionary key, we can see using this name mangling we have avoided the collision. Now next topic is getter and setter method in Python. So Python convention, or as per the Python convention, does not use any getter or setter method on the data attribute of a class. So in other languages such as Java, C#, we use getter and setter method in order to access the attribute value, and all the attributes are defined as a private attribute. So that convention is not followed by the Python. Instead, it uses this syntax for assigning it and for accessing the class or the object dot attribute name convention, because it increases the readability of the code. That doesn't mean that you cannot attach any method when you are accessing or modifying the attribute value. We will see in upcoming session how to intercept the attribute access. So you can attach methods when you are accessing attribute or modifying the attribute. So in order to invoke any of the business logic when you are accessing or modifying the class attribute or a instance attribute, but this syntax remains the same even if you are invoking some function also. So there are no getter and setter method for the Python, which simplifies the code and it increases the readability of the code. Next topic is class name aliasing. So you can define a class and in order to create a short form you can attach it to the any variable name. Because the class in a Python is a first class object, you can attach it to the any variable, and if you try to invoke constructor on that particular variable, it will create an object of that particular target class. So as you can see here, person class is assigned to the PP, and using that it is created object, and if you check the type of object, it is a type of person. Now next is creating a collection of object, user defined class object, and invoking dictionary comprehension or list comprehension on collection of a user defined object. So here we have created a class employee which contains these attributes, and we have created objects 5 employees inside the list collection. And now using the attributes or the instance attributes of a class, we can either filter it or we can create another collection by invoking any instance method or a class method on it. Okay, so here in this example we are filtering the data which is stored inside the list based on the attributes of a instance attribute of a class. So for this example we are filtering the employees based on their location and their salary. So first we are iterating over each employee inside this employee database, and we are extracting the name of the employee only instead of whole employee object. We are only extracting the name of employee who is having this string in their address and their salary is greater than this given value. So it will only return the employee from these 5 employees which satisfies this criteria. So let's execute it, and if we can see here with this employee data, there are 2 employees with this given name which satisfy these 2 criteria of having address in this city and the salary which is greater than this defined salary here. Okay, so same as for the second employee, if you are checking this, then this is the city and it is the salary greater than this given salary. So same as we saw for the name tuple object, you can use the attribute, either the instance attribute or the methods inside the list comprehension in order to either filter the object or in order to transform the object into the another collection. So that brings us to the end of this video.